Welcome to Warwick Science's Film Practical, which is looking at rock types. Now what you can see laid out in front of you there are the three major types of rocks that we have, and rocks are classified by the way that they're formed. So we have sedimentary rocks, igneous rocks, and metamorphic rocks. As always, there is a prac write-up, so can you please stop the video or pause the video, copy that down, and then when you're ready to go you can restart the video again. Okay, the major thing that you need to know for each of these is the characteristics of each of the three types of rocks. You need to know how they're formed and some basic examples of each. So let's have a look at sedimentary rocks to begin with. Okay, this is our most common one, which is limestone, and limestone you find in and around the ocean areas. Okay, so what you can see here is, and you need to have a look very closely, and this is probably not a great one, but you can see layers. So a sedimentary rock is formed essentially by layers of sediments, and sediment's a small amount of material, and they basically fall down, they get compacted, they get cemented together, and you end up with a sedimentary rock. Now here, of course, you can see that they've got shells, and this is the important part with a sedimentary rock. These shells contain a substance called calcium carbonate, and calcium carbonate actually reacts with an acid, so these will chemically weather, but it'll only be substances that contain the calcium carbonate, or the animal shells like crabs, crustaceans, and things of that nature. So that's our basic limestone. Now this is quite a beautiful example of mudstone, and again you can see now that quite definite banding and layers that have been formed, and these are different size sediment. So as the water washes down, smaller sediments fall first, then heavier sediments fall, and you get this layered approach. It gets squashed together, and it ends up being cemented to form a sedimentary rock. Now this is a really nice example. This is sandstone, and again you can see the different layers of sand material that are present there. Okay, you can see that just that white one there. There's another darker layer through there. Sandstone is for good quality sandstone very expensive, and this one cost about $15, just this little piece. So again, you can see, and this one's been polished a little bit. This side hasn't. That's still relatively rough, but this side's been cut and polished a bit, and you can see those particular layers in. Now again, sandstone, if you put that into acid, will not chemically weather, because it doesn't contain those animal shells. This is an interesting one. This is like a licorice all sorts, and this is conglomerate, and conglomerate's got all different size rock particles in it, or sediments in it. It's got big, it's got little, it's got in between, it's got all different shapes, and essentially a whole lot of things get washed up, they get all compacted together, they get cemented together, and we just give it the name conglomerate because it's a little bit of everything. Okay, so that's conglomerate rock. Now again, please, as we go along, fill in the various parts of the prac write-up. Our next one is igneous rocks, and igneous rocks, ignite means born of fire, essentially. So these are ones that come out of, or originate in the Earth's interior. Now this is a substance called basalt. Now basalt has only got really little crystals in, and probably the video doesn't do justice to it, but it's got small little crystals in it. This is what we call an extrusive igneous rock, which means that it cools above the surface of the Earth, so on the surface above it, not underneath it. So it's got very small crystals, because the size of the crystals actually is determined by the way that it was cooled. The fact that it cools quickly, you end up with a small crystal size. This is our classic, and this is granite. Okay, and this is a bit of an ugly piece when you think about it. not polished, but this is what we call an intrusive metamorphic rock, and that basically means that it cools below the surface. So the magma comes up, pools in an area, cools, and then gets exposed. This is a better sample up here, and I bought this one for $5 from Bunnings, and you can see there lots and lots of crystals in the actual rock itself, and you can see it sort of glycering there with the various crystals that it has. Okay, big crystals, because this one cools under the ground. Now, sometimes when they cool so quickly, they don't end up with any crystals, and an example of this is this one, which is what's called volcanic glass or obsidian rock. Now, as you can see, it's nice and shiny, looks like glass, and is a dark color, and that's why we call it volcanic glass. This has come up, it's cooled so quickly that the crystals haven't actually had any time to form, so as a result of it, you get this this look. Very, very expensive rock, very nice rock as well. Now, our last sort are metamorphic rocks, and metamorphic rocks are sedimentary rocks and are igneous rocks that are actually impacted upon by heat, by pressure, or heat and pressure. Contact metamorphism results from heat, regional metamorphism results from pressure. Now, this is quite a lovely one here. This is slate, and back in the 70s and 80s we used it a lot for tabletops and also for floors. Okay, now you can see it again, it's got some layers attached to it. Okay, they're thin, it tends to flake off and break in small flat pieces. So this is one that we call slate. This is what slate starts out as. It actually starts out as mudstone. Then it goes through the metamorphism. It ends up as a substance called shale, and then the shale has more metamorphism, and it ends up looking like slate. Okay, so that's the transformation of the mudstone. Here we have one that most people know, which is marble. Okay, and marble is a beautiful rock. As again, you can see the various lines through it, which you can see some layering in here as well, and that starts off as common as mud limestone. So once limestone gets metamorphosized, it gets metamorphosized into a marble. This one has been cut and polished up a little bit, so that's the internal of it, but a very hard rock. Okay, it does break easily, so it's very brittle, but it's a very strong rock. Our last sort, and you might be able to guess where this one comes from, this is gneiss. Now again, you can see this banding or this layering approach, and this is one of the features that gneiss has. You can also see the crystals of it, so if you guessed that it is granite, then you are correct. Okay, because obviously it starts off as granite and then it metamorphosizes into gneiss. Again, hard rock there. Now, those are the three types of rocks as some examples. So if you'd like to complete the worksheet or the prac write-up, then check in with your teacher to make sure that everything is up to speed. Thank you for accessing Rock Science's Film Practical on rock types.